Every recommendation you see, every price that changes, every prediction made about your behavior is powered by a system most people never truly understand. Machine learning isn't magic, it isn't intuition, and it isn't intelligence in the human sense. It's something far more unsettling, a process where machines learn patterns from the past, reinforce them automatically, and apply them at a scale no human mind could ever manage. Once you understand how machine learning actually works, you stop seeing AI as smart and start seeing just how powerful and fragile these systems really are. Welcome to AI Unlocked, the channel where we explore artificial intelligence, future tech, and the tools that are changing the world. Today, we're diving into the science of machine learning explained. Machine learning doesn't learn the way humans do. There is no curiosity, no insight, no comprehension. At its core, machine learning is statistical pattern recognition. Models are fed vast amounts of data and asked to minimize error, to get better at predicting outcomes by adjusting internal parameters again and again. When a system learns, it isn't discovering truth. It's finding correlations that reduce mistakes. That distinction matters, because accuracy can exist without understanding, and confidence can exist without correctness. For humans, experience is lived. For machines, experience is data. Every image, transaction, sentence, click, and sensor reading becomes a lesson. The more data a model consumes, the more refined its predictions become. But data is never neutral. It reflects human behavior, bias, gaps, and history. If the data is skewed, the learning is skewed. Machine learning doesn't rise above its training. It amplifies it. What the system learns is not how the world should work, but how it has worked before. Training a machine learning model is an iterative process. The model makes a guess. The guess is compared to reality. The error is calculated. Parameters are adjusted. This loop runs millions, sometimes billions, of times. Over time, the system becomes highly specialized at one task: recognizing faces, translating language, predicting demand. But specialization comes with brittleness. Outside its training boundaries, the model can fail in unexpected ways. It doesn't know when it's wrong. It only knows how confident it feels. Machine learning excels at prediction, and prediction is power. Knowing what someone is likely to buy, watch, believe, or do next allows systems to shape behavior subtly. Recommendations guide attention. Rankings influence decisions. Scores determine access. Machine learning doesn't just observe reality, it nudges it. Over time, predictions influence outcomes, and outcomes feed back into training data. The system begins reinforcing the future it predicts. One of machine learning's biggest limitations is that it detects patterns, not causes. A model may learn that two things often appear together, but not why. This can lead to accurate predictions built on fragile logic. When circumstances change, the model doesn't reason. It guesses based on outdated structure. This is why machine learning can fail spectacularly during rare events, crises, or shifts in behavior. The system isn't wrong in principle, it's blind to context. And this is where machine learning becomes far more than a technical tool, because once predictions start shaping decisions at scale, the system isn't just learning from the world, it's actively reshaping it. Stay with me. The next part exposes what happens when machines begin learning from their own influence. When machine learning systems act on their predictions, they alter the data they later learn from. A recommendation engine promotes certain content, which gets more engagement, which confirms the model's belief that the content is valuable. A risk model denies access, which limits opportunity, which reinforces predicted outcomes. These feedback loops are not malicious, they're mathematical, but they can lock systems into self-reinforcing cycles that become increasingly difficult to escape. Many modern machine learning models are so complex that even their creators cannot fully explain their decisions. Inputs go in, outputs come out. The reasoning in between remains opaque. This black box nature creates a serious challenge in high-stakes areas like healthcare, finance, and justice. When a system denies a loan, flags a risk, or recommends a medical action, explaining why becomes nearly impossible. Accountability weakens when reasoning disappears. Machine learning models are trained to generalize, to apply learned patterns to new situations. But real life is messy. Edge cases matter. Outliers exist. Humans adapt quickly to novelty. Machines struggle. A model trained in one environment may fail when moved to another. This is why systems that perform brilliantly in controlled settings can break down in the real world. Intelligence without adaptability becomes brittle. Despite the power of machine learning, humans remain essential. People choose what data is collected, what objectives are optimized, and what trade-offs are acceptable. A model doesn't decide what success means. Humans do. The danger arises when systems are deployed without oversight, monitoring, or the ability to intervene. Machine learning works best not as an authority, but as an instrument guided by human judgment. The future of machine learning points towards systems that learn continuously, adapt in real time, and operate across multiple domains. Models will become more efficient, more specialized, and more embedded into everyday systems. But progress won't come from scale alone. It will come from better understanding limitations, when to trust predictions, when to question them, and when to stop them entirely. Machine learning isn't intelligence in the way humans understand it, but it is one of the most powerful pattern engines ever created. And as these systems continue learning from our behavior, our choices, and our history, the future won't just be shaped by what machines learn, but by what we allow them to learn from us. If you found this episode thought-provoking, make sure to follow the channel, subscribe, and hit the notification bell for more cinematic explorations into how intelligence is built, deployed, and misunderstood. And in our next video, we move from theory to the body itself, the future of personalized medicine. A deep dive into how machine learning is beginning to tailor healthcare to individual biology, risk, and behavior.